Welcome to the class. Till time we have seen about various aspects of the turbine. One of the parts of the turbine is basically nozzle, and today's class is devoted for solving examples about nozzle. So here we will see how to solve examples which are given for nozzle flow, basically especially for the steam flow through the nozzle. So we have first example which states that steam expands in a nozzle from boiler condition of 10 bar and 300 degrees Celsius to condenser conditions of 2 bar. What is the shape of nozzle? If mass flow rate of the steam is 1 kg per second and nozzle inlet velocity is negligible, then find out minimum cross section area. Consider steam flow to be isentropic and critical pressure ratio as 0.546. So here now the given thing for us, first let us plot TS diagram. So as we know, we will be here 3 to 4. We are in the state of nozzle 3 to 4 as per our conventions of the cycle. So here things given to us are P3 is equal to total condition, since we are told that velocity is negligible. So P3 is equal to P naught is equal to 10 bar and T3 is equal to T naught is equal to 300 degree Celsius. So 300 plus 273 is 573 Kelvin. So it is given to us. Now we are also told that condenser P4 is equal to 2 bar. Now we are also knowing that m dot s mass flow rate of steam is 1 kg per second. We are told that flow is isentropic. So we are told that S3 is equal to S4. We have also been told that P star upon P naught is equal to 0.546. So this is the critical condition. We know that if a nozzle is a CD nozzle, then in case of CD nozzle, minimum cross section area will attain Mach number for the expansion from subsonic to supersonic, and P star is the pressure at the sonic condition, and then we will have the flow expanding from P naught to P star, but here flow is expanding from P3 to P4, and now we are going to see if P star is less than P4, then we will not have expansion in CD nozzle. If P star is more than P4, then we will have expansion as the convergent divergent nozzle. We have seen that the choking condition leads to a particular pressure in the exit. If pressure is below than that, then the flow is in a CD nozzle. So we can find out P star is equal to P naught into 546. So since P naught is 10, it will be 5.46 bar. But we are told that P4 is equal to 2 bar. But so since P4 is less than P star, we have flow in a convergent divergent nozzle. Since flow has already been choked by the pressure difference, and then P4 is so low than P star such that flow has to be in the convergent divergent nozzle. So having said this, we will move to the next point where it is asked to us to find the minimum cross section. We know that m dot s is equal to rho a v, where we will take v as v star, a as a star, rho as rho star, but instead of that we can say A star into V star divided by specific volume of star. So, A star is equal to m dot s into specific volume at sonic condition divided by velocity at sonic condition. So, here we will do this. We need to find out what is the area for m dot s, which is given to us V star and specific volume at star and velocity at star. So, we will do one thing. We can find out what is the entropy. We will go to the steam table, and from the steam table we know P3 and we know T3. We can find out H3 and also we can find out S3. So, S3 is known to us. So, knowing the S3, we can do two way this calculation. Either we can go to the condition which is corresponding to 4 and find out at what is the state in which we will have this entropy S3. But instead of that, we can do one more thing. We can go, since by that means we will find out exit area. Here we are asked for minimum cross section area, which is for the throat, and this is the expression for minimum cross section area for the throat. So, now our target is to find out V star and V star, specific volume and velocity at the throat. So, let us see how we can find out. Now, we know the P star. So, here let us assume that we are somewhere here in the star. So, we know that S star is equal to S3. So, basically we know S3 is equal to S star. So, knowing this, and further we know P star is equal to 5.46. So, we will go to the steam table and see for P star is equal to 5.46, what is the SG and what is the SF. Now, we will see if S star is less than SG or S star is more than SG. If S star is less than SG, then we will have to find out X star. Otherwise, for this condition, we can directly get enthalpy star, we can directly get specific volume. So, these two quantities we can directly get. Otherwise, in the case where S star is less than SG, we will first find out X star. From X star, we know H star is equal to HF plus X star into HFG, and then similarly we will also find out V star. So, by this means of calculation, we have found out V star. Now, our target is to find out velocity. V star we can find out using the formula 44.72 into H naught minus H star square root. So, we know now H star by any means, that we will put over here. We know H naught, basically H naught is equal to H3, that is also known to us, and then we can know V star. So, knowing the V star and knowing the specific volume, we can put everything in this formula and we can find out what is the minimum cross section. In this particular example, S star happens to be more than SG. So, we do not have to find out dryness fraction, we just have to find out H star from the steam table and we have to find out specific volume. So, I hope this is the way to solve this example. I have elaborated the procedure how to solve the example. So, we will solve the next example. Next example says that steam expands in a nozzle from boiler condition of 10 bar 300 degrees Celsius to condenser condition of 1 bar. Convergent part of the nozzle has ideal flow, but there is enthalpy drop of 15% in the divergent part of the nozzle. Find the minimum cross section area of the nozzle if mass flow rate is 1 kg per second and nozzle entry velocity is negligible. If exit diameter is 25 mm, then find out total number of nozzles required. Consider critical pressure ratio as 0.546. So, here as well we will first find out the TS diagram. Here as well we will have 3 and 4. So, given conditions are T naught is equal to T is equal to 300 degrees Celsius is equal to 573 Kelvin, P naught is equal to P3 is equal to 10 bar, and then we are also told that P4 is equal to 1 bar. We have been given that P star upon P naught is equal to 0.546. So, we are explicitly told that we have a CD nozzle. So, we will say somewhere we have star. So, this is star, this is 3 and this is 4. So, in the CD nozzle we have this part as isentropic and this part has 15% loss in enthalpy. So, we are supposed to find out minimum cross section for m dot s is equal to 1 kg per second. Let us first find out minimum cross section. Again I will write down the formula. M dot s is equal to A star into V star velocity star divided by specific volume star. So, from this formula again A star is equal to specific volume star into m dot s divided by V star. So, given thing to us is m dot s. So, we have to find out the specific volume and velocity at the sonic state, but it is very simple. We should follow the same procedure what we did follow in the last example. We will go into the steam table, and in the steam table we will put P3 and T3 state. For the P3 T3 state I will find out S3 and H3, which is basically S naught and H naught. These things we would find out. Now we are told that P naught P star upon P naught is equal to 0.546. This leads to P star is equal to 5.46 bar. So, I will go to 5.46 bar, which is P star, and for that I will see where S star is equal to S naught. Now, I will again see if Sg is greater than S naught or Sg is less than S naught. Accordingly, I will put star is above the dome, inside the dome, or outside the dome. So, if Sg is greater than S naught, then we will find out X star, and if this is not there, then we do not have to worry. Knowing the S star, we can find out H star, and we can also find out specific volume. Otherwise, if Sg if Sg is greater than S naught, then we do not have to bother. If Sg is less than S naught, then we have to find out X star, and knowing the X star, we will find out H star and specific volume. But if Sg is greater than S naught, we will directly go to superheated part of the steam table, and there we will find out H star and specific volume. Knowing these specific volume and H star, we can find out V star. is equal to 44.72 H naught minus H star square root. So V star is equal to 44.72 H3 minus H star bracket square root. So this is what we can do, and then we can find out what is the velocity at the star state. So knowing this condition, we can put that velocity here, we can put that specific volume over there, and then we can put mass flow rate and find out A star, where A star is minimum cross section. So this is how the procedure to find out minimum cross section is. Now we are told that what are the number of nozzles if we have exit diameter as 25 mm. So we know rather A exit, so A4 is equal to pi by 4. We will rub this. So for this now we have to find out what mass flow rate through one nozzle, and then we will divide this for the total mass flow rate, and then we can find out number of nozzles. So first thing is A4 is pi by 4 d square, and d4 is given as 25 mm. So we can find out A4. Once A4 is found out, again dot S is equal to number of nozzles into m dot S from one nozzle. So we will say it as NZ. So this is equal to N into area at the 4 into velocity at the 4 divided by specific volume at the 4. So N, which is number of nozzles, is m dot S into specific volume at 4 divided by A4 into V4. Now here we will be in trouble, since m dot S is known to us, A4 is known to us, but we do not know again V4 and specific volume at 4. So that we need to find out, but for that we can see that how to find out. First V4, I can think how to find out V4. The formula is 44.72 into, I will write down it as square root of H naught minus H star. This flow is isentropic, so it is square root plus 0.85 into H star minus H4 dash. So this point is 4 dash, since we are told that after the nozzle there is loss, and we will put it here. So isentropic point is 4 dash, real point is 4. So we have to first find out what is the isentropic 4 point. Same procedure we will follow. We can do one thing. This 0.85 is the loss of 15%, accounting this is the enthalpy drop in the divergent portion. This is the enthalpy drop in the divergent portion, this is the enthalpy drop in the convergent portion. So this summation is the total enthalpy drop in the nozzle, and this is the velocity. Now we can find out H4 dash. For that we will again see S3 is equal to S naught is equal to S dash, S4 dash is equal to S4 dash. So we will go to the steam table, and then in the steam table we will go to the P4 is equal to P4 dash is equal to 1 bar. We will go in that and see where we can get S4 dash as equal to S3. Again we will have few things. Sg at 1 bar can be less than S4 dash, can be less than S naught, or SF or Sg at 1 bar can be more than S naught. Now if Sg is less than S naught, then we need to find out x4 dash, and if x4 dash is known to us, I can find out h4 dash and v4 dash. But if Sg is greater than S naught, then we can directly get from the superheated part of the steam table h4 dash and v4 dash. That is how we can find out. So these are the specific volumes and enthalpies. So this is how I will know now h4 dash. I will put this h4 dash here, and then I know what is the velocity at the exit of the nozzle. Once I know velocity, I can put that velocity over here. I knew area, I should know now V4. So there is a way what we can find out V4. We know now that there is 15% of loss. We know now there is 15% loss in the divergent section. So for that we can do this way, H star minus H4 dash into 0.85 is equal to H star minus H4. Here from this earlier method we have found out H4 dash, we have found out H star, we know H star, then we can find out H4. So once H4 is known, we can find out X4. Since we know that X4 H4 is equal to HF plus X4 into HFG if H4 is less than HG. Otherwise this is X4 is 1, then we don't have to bother. Then in that case, if H4 is greater than Hg, then directly we can get the specific volume V4 from the superheated part of the steam table, which is not the present case. This is a wet steam, so we need to find out X4. So H4 is equal to HF plus X4 into HFG. Now we know H4, we know HF, we know HFG corresponding to 1 bar, and then we can find out X4, and then using the specific volumes for the liquid and fluid at the saturation state, we can find out V4. So now we know V4, and then this is how we can find out total mass flow rate of the steam is given, and then we can find out total number of nozzles. Here we should remember that this number will always be an integer, this cannot be a float. So for that, whatever be the nearest integer, we have to consider that as an answer. This is how we have to solve the example which is given to us in this form, which will account the losses. So now let us see the next example. Next example states that steam expands in a convergent divergent nozzle from boiler conditions of 20 bar 300 degrees Celsius to the steam condenser which is at 3 bar. Mass flow rate is 0.3 kg per second. Estimate throat and exit areas without using HS diagram if expansion of the steam follows PV raised to 1.3 is equal to constant. Also estimate throat and exit areas if the discharge coefficient is 0.98 and the velocity coefficient is 0.92. In either cases, consider critical pressure ratio as 0.546. Again, we will plot the TS diagram, and as per the TS diagram, we are in 3 to 4 where we are given P3 is equal to P naught is equal to 20 bar, T3 is equal to T naught is equal to 300 degrees Celsius is equal to 573 Kelvin. We are told that P4 is equal to 3 bar m dot s steam flow rate is 0.3 kg per second. Let us consider part A. Here in the part A, it is told that PV raised to 1.3 is equal to constant. We are told that PV raised to 1.3, and here we are specifically told that we cannot see the steam table. So, there are ways by which we can solve the example. We can here as well, it is not told, but still we can consider V3 velocity at 3 is equal to 0 meter per second. So, expansion is told to have an isentropic index of 1.3. So, in this case we know that basically change in kinetic energy, which is V4 square by 2 minus V3 square by 2 is equal to K upon K minus 1 into V3 minus P4 V4. So, this is what we can use, but before that we are solving for A, and then for that we will first solve for the throat. So, we know that P star upon P naught is equal to 0.546. So, for us P star is equal to 0.546 into 20 bar. This is P star value for us. Now, our objective is to find out area, minimum area, and so for that minimum area again we know the formula. Mass flow rate is given to us, m dot s is equal to A star into V star velocity star into specific volume star. So, A star is equal to m dot s into V star divided by velocity star. So, here A star is to be found out, mass flow rate of the steam is given, and we need to find out specific volume and velocity in the throat. Basically, we had seen till time that we can use the formula directly of velocity is equal to 44.72 into square root of enthalpy drop, but for that we have to find out enthalpy at the star condition. Suppose star is here. For that we have to use this pressure, go to the steam table, find out, compare. This is what we can do, but here we cannot do that, since it is told that we cannot see the HS diagram or steam table. HS diagram, we cannot see the HS diagram. So, Mollier chart, we cannot go to the Mollier chart, otherwise it is very simple. So, before that what we can do is, without solving, without taking the enthalpy directly from Mollier chart, we can find out the velocity using this formula, where we can use the formula for velocity as this V star square. Here we can find out V star square by 2 is equal to K upon K minus 1 P naught V naught minus P star V star. We are told that P naught V naught raised to 1.3 is equal to P star V star raised to 1.3 is equal to P4 V4 raised to 1.3. So, using first relation, we know now P star upon P naught, which is 0.546. So, we know P star, we know P naught, and then from the steam table we can find out V naught corresponding to 20 bar and 300 degree Celsius. So, this is what we can find out from the steam table. So, knowing this, we can, knowing this P naught, knowing this V naught, we can, and P star we can find out V star. So, specific volume at the sonic state is found out. So, P star is known, V naught, V star is known, P naught is known, V naught is known, K is equal to 1.3, we found out V star. So, this formula is basically telling that the change in kinetic energy is leading to the change in specific volume due to the expansion, as PV raised to 1.3 is equal to constant. So, knowing this, we can put the specific volume and V star and A star can be found out for given mass flow rate. So this is how we can find out the throats area. Similar procedure we can execute for the finding out exit area, where now m dot s is equal to A4 V4 upon V4. So by this formula, where we have P naught V naught raised to 1.3. Using this we will find out V4. So V4 is known, A4 is to be found out. So A4 is equal to m dot s V4 divided by V4. So these two things are known. So we have to find out V4. So same procedure we can follow. V4 square by 2 into K is equal to K upon K minus 1, P naught V naught minus P4 V4. V is specific volume. So knowing these things, we would find out what is the velocity at the exit, and then we can put it in and then find out what is the area. So this is what the procedure we would have adopted for finding out the exit and the areas at the throat. Now in the part B, so we will rub this, and then in the part B we are not told that there is PV raised to 1.3 constant, but we are told something else, where we are told that there is a discharge coefficient of 0.98. So there is a change in mass flow rate. So for that part B, now we have discharge coefficient CD is equal to actual mass flow rate divided by ideal mass flow rate, and that is told to be 0.98. Then we can find out m dot s dash is CD is m dot s divided by CD. Actual m dot s is known, CD is known, we can find out. Further, this is the condition, this is the 4 dash and this is 4. Then we are told that there is a discharge coefficient. So for discharge coefficient, this is 4 dash and this is 4. So for discharge coefficient phi, as what we know, it is V4 divided by V4 dash. So these are the facts, and now we are told to find out throat area, suppose to start with. So again A star is equal to basically m dot s is dash is equal to A star V star divided by specific volume. So this is the formula which we know. So knowing this, we can find what are the things which are known to us. Those things we will put. So we know that P, in either case, P star is equal to 0.546 into P naught, and this is known to us. So we know what is the value of P star. Then we can find out the rest of the things. So here we are told with velocity coefficient V4 by V dash, and P star is equal to 0.546 P naught. Now we know that we can go to the steam table, and then from the steam table we know, we will say that in the steam table we know S3, and then S3 is equal to S4. So we will find out the 4 dash. S3 is equal to S4 dash. So this S4 dash is known to us. Knowing this S4 dash, we can if required we can find out x4 dash. Similarly, we can do it for the throat. So, we can know S star, basically S3 is equal to S star dash, and for that we will find out X star dash. So, we will know the dryness fraction at the throat and also the dryness fraction at the exit in the ideal condition, and knowing this we can find out H4 dash and we can find out H star dash. Then knowing this we can find out the formula, which is V star dash is equal to 44.72 H naught minus H star dash square root. So, this H star dash is known to us, we will put here, H naught is known to us, we will put here, and then we know now V star dash. So, this V star dash is known to us. So, once V star dash is known to us, we will use the formula for the mass flow rate and then this V star dash, and similarly using this we can also find out specific volume. So, specific volume dash is also known to us. So, velocity is known to us, this specific volume is known to us, we know ideal mass flow rate, knowing the discharge coefficient we can find out area at the throat. If we execute same procedure, instead of star we will have at 4, then we can know exit area also. Okay. So, there are two ways, however, we can make use here itself of phi, and then knowing the velocity as dash we can find out the velocity in reality. In reality velocity is known to us, then we can make use of that velocity to find out enthalpy at that state. Knowing that enthalpy we can find out the specific volume, and then we can use that everything to find out the area in reality where we would have actually the actual mass flow rate in that condition. So, this is how we will solve the example which is given for us for the nozzles. We will see about rest of the things in the next class. Thank you.